Next, we are adding the EKS cluster resources. We'll be using the AWS EKS cluster resource, and we'll name our resource main. Start with the name of the cluster, which we'll fetch from the local variable we had defined in the locals.tf. We'll pass the role ARN, which will come from AWS IAM role.assume role to ARN. Next, we are passing in the cluster version from var.cluster version. Next, we are adding the enabled log types, which will be passed from the enabled cluster log types variable, which is a list. Then we have the configuration where we are passing in the security group IDs, which should be var.security group IDs. Make sure this variable is a list. Initially, we created it as a string, so just ensure it's a list of strings like this. Pass in the subnet IDs, which come from the subnet IDs list of strings. Finally, we'll specify whether we want the endpoint public access or endpoint private access. For this tutorial, we'll be using the endpoint public access to allow our cluster endpoint to be accessible outside the VPC in which we are creating this. You can read more about the endpoint access in the EKS documentation. We'll add tags by merging the tags variable with the name of the cluster as a map. And then we'll add the timeouts block. We have the create timeout, which will look up from the var.cluster timeouts. We are looking up for create key, and if it's not specified, we pass the default value as null. We'll repeat this 2 times, just copy and paste it 2 times. And then here we'll do the update. We'll be looking for the update key within this object or this map. Then lastly, we have delete, and we'll be looking for the delete key. If it's not there, we assign null. Make sure you use a single equal sign. Finally, we'll do depends on. This resource will depend on the IAM role policy attachment. So basically, we need the AWS IAM assume role, and then we need the AWS role attachment, and then the main role attachment, which is this one. So for these two, you can just choose one of them. This one depends on the role, so we can just remove the role itself. And with the managed policies, we can add the AWS CloudWatch log group main. We'll be creating this log group resource later on. Next, we'll be creating the time resource that allows us to pause for a given duration while any of the actions specified within it are taking place. Our resource will be the time sleep resource, and we'll name our resource main. Then we need to add the create duration, which will come from var data plane with duration. Then we'll add triggers, which will be a map of key values. So we'll have the cluster name from the AWS EKS cluster.main.name. Then we have cluster endpoint from AWS EKS cluster.main.endpoint. We have cluster version from the cluster resource, and we just take the output version. Then we have the cluster certificate authority from AWS EKS cluster.main.certificate authority.data. So the time sleep resource allows you to create a gap of time between when this resource is created and when the resources that depend on this resource will be created. So wherever we'll be using the time sleep.main, that resource will wait for this duration before it can get created or it can get updated in case any of these keys or triggers get changed along the way. Next, we'll create our CloudWatch log group using the CloudWatch resource, and I will just name it main. It will be created based on a condition, and the condition will come from the variable create CloudWatch log group value. So if it's true, we pass 1. If it's false, pass 0, so that no resource is created. Name of this resource will be a string, AWS EKS. Then we pass in the cluster name, which is a local cluster name. At the end, we add /cluster. And retention in days to be var.cloudwatch log group retention in days. Then we have KMS key ID, which will be var.cloudwatch log group KMS key ID. We have tags, where we'll be merging the var.tags with the name tag passed in as a map. So this is the name. Make sure you pass it down here. Let's go on and create the cluster add-ons. This one will be created from AWS EKS add-on. Our resource will be named main, and it will be created from a for each loop. And then here we do for key value in var.cluster add-ons, we return the value if var.cluster. So we can put a condition here if v is not equals to null. Depending on the resources you are creating, you can add more conditions here. So we'll just supply the cluster name here from AWS EKS cluster.main name. Add-on name from trying each value name, and if that particular object didn't have a name, we just take the key value as the add-on name. For the add-on version, it will be coming from the current object or from the data resource that we created a while back. We are coalescing values, so we'll start with the first one that is going to try each value add-on version. If it's not there, it will return null, and then it will be coalescing that with the data .aws EKS add-on version.main. We'll be taking each .key, and then we take .version. So this data resource is created based on the map of objects that are passed in this variable. Therefore, the keys that are coming from this map can be used on this data resource directly. That's why we are using the key. And then from this selection, we get the version of that particular add-on that has been picked. Then we pass in the configuration values. Here we are trying each value configuration values. If they are not specified, we pass null, reserve. So here also we are trying each value reserve. If it's not passed, pass null. So this try function checks the first value. If the first value doesn't exist, it takes the second value as the default. And here coalesce, what it does, it checks if any of this value is a null, it removes it, and then you remain with the value that is not a null. So we have resolve conflicts on create. This one will take two values again. So it will be each value that resolve conflicts on create, or by default, we will overwrite. Then we have resolve conflicts on update. We'll take the same format, each value resolve conflicts on update, or we overwrite. Then we have the service account role ARN. The add-on might need a service account role. Here we check our map if it has the service account role ARN. If not, we don't pass anything. We just resolve to null. And now we have timeouts. The create timeout that comes from each value timeouts create. If this one isn't specified, we use var cluster add-ons timeouts create. If that one doesn't resolve to a value, we pass in null. It's the same for update and delete. Then we'll add dependencies. This one depends on the Fargate profile module, which we are going to create next. And then now we can pass the tags. Then for the last resource section of this module, we are going to create our Fargate profile module. The source of this will come from the profile module that we created previously, this one right here. And it will be created for each loop. And this loop will be using the values returned from this for loop. So we have for each key value in var.Fargate profiles. Just verify this is the correct variable name we specified. You can see it is. Then we return a value if v is not equals to null. So what we are doing here is basically creating a map of objects that can be iterated using a for each loop. Then we need to pass the cluster name, which will come from AWS EKS cluster.main. Then we need to pass in the project name also. So we'll just forward this project name from this variable, which is a shared variable. For the profile name, we have try each.value.name. And if the name isn't specified in this particular object or this map that came from the set above, then we'll just take the key as the profile name. For the selectors, we are just taking each.value.selectors. Subnet IDs, we will pick each.value.subnet IDs. And for the unique ID, the same. We'll also add the create IAM role, which will use the same approach. So each.value.create IAM role. And now we have IAM role attach CNI policy. We'll have each.value.IAM role attach CNI policy. For the additional policies, we'll pass the same. For the pod execution assume role, we'll do the same thing too. And then we'll pass the tags using each.value.tags. These ones will be merged with the profile name, which comes from each.value.name. If that's not specified, we can use the key. This is the last resource we are creating. Now we have to add the outputs. We've been skipping the outputs for these two modules, so let's specify some outputs so that our module can communicate with the dependent modules. For this one, we'll start with the first output, which is the cluster name, whose value will be AWS EKS cluster main.name. It won't be name, it will be cluster name. Second output will be the cluster endpoint. You can add as many outputs as you will need in your setup. Here we are just outputting the cluster endpoint from the EKS resource. Next one is the CS certificate, whose value will come from the cluster certificate authority. Then the cluster identity. So this will show us the identity provider. If the cluster has more than one identity provider, it will be listed in this output. So it will still come from the cluster.main.identity. Then you're going to output the cluster certificate authority, whose value still comes from the EKS cluster.main.certificate authority. Then we select the first object, then we select .data. And with this, we mark the end of this EKS cluster module named Fargate Cluster. So let's review what we've just done. We started by specifying the variables, which are grouped in different portions. We have the common variables that are shared across resources, the IAM, the KMS variables, the EKS variables, the add-ons, and then we finish with the CloudWatch and the profiles. Then under versions, we had two required providers, the AWS provider and also the time provider. And then we also put the required Terraform version. When we move to the outputs, we output the cluster name, endpoint, CSAT, the identity, and then the certificate authority data. In the main, we created a few sections. We started with the optional KMS key that is created based on this variable. Then we also created the assume role for the cluster and attached various permissions and also some optional permissions. Then now we created the main cluster resource and passed in the required values. Then we created the time sleep resource that allows a Terraform setup to pause for a given duration, which is this one, whenever any of these triggers have a change. Created the log group that is an optional resource also that can be specified when initializing this module. We also added the add-ons resource and finished with the profile. Next, let's go to our main module and finish setting up the remaining parts.